A journey begins. The Sun and Parker's daring dive. The story of humanity's exploration of the cosmos has always been one of bold ambition and fearless curiosity. Imagine a realm so vast that our entire planet shrinks to a mere speck, a place where temperatures soar beyond anything we can comprehend, and the very laws of physics appear to twist and sway. This is the realm of the Sun, our very own star, a cosmic titan that holds within its blazing heart the power to create and sustain life. And today, we are not just content to admire it from afar. No, today, we are taking a daring leap into the unknown, inching closer than humanity has ever dared to go before. On November 21st, 2021, a momentous event occurred. The Parker Solar Probe did the unthinkable. It approached the Sun's corona, the fiery outer layer that has long been shrouded in mystery. This layer, which scientists once deemed untouchable, is a cauldron of unimaginable heat and volatility. But why risk sending a probe into such an inferno where temperatures can vaporize metal in seconds? The answer is simple. The Sun, with all its blazing chaos, still hides secrets we are desperate to uncover. It's not just about curiosity. It's about the future of science, the future of energy, and perhaps even the future of humanity itself. The Sun, you see, is far more than an ordinary yellow dwarf. At 4.6 billion years old, it's a middle-aged star, but don't let that fool you into thinking it's winding down. On the contrary, it continues to burn with an intensity that shapes everything around it. Its surface reaches a blistering 5,530 degrees Celsius, hot enough to vaporize almost anything. Yet, as astonishing as that is, the Sun's corona, the very outer layer Parker set out to touch, burns millions of degrees hotter than the surface itself. Yes, millions. It's a paradox that has puzzled scientists for decades. How is it possible that the outermost layer is hotter than the surface? Comment below with your theories. Why do you think the Sun's corona is hotter than its surface? We'd love to hear your thoughts. Theories abound, each one more intriguing than the last. Some scientists believe that magnetic shock waves generated by the Sun's turbulent activity might be transporting energy up to the corona. Others suggest that charged particles, hurtling through the Sun's powerful magnetic fields, could be the key to this mysterious temperature inversion. Whatever the cause, it's a question that goes right to the heart of solar physics, and Parker was built specifically to get us closer to the answer. Equipped with cutting-edge instruments and a revolutionary heat shield, Parker is humanity's fearless emissary to the Sun, our blazing beacon in the dark. As Parker inches ever closer to the Sun, its heat shield withstands temperatures exceeding 1,370 degrees Celsius. To give you some context, that's hotter than a blast furnace or even a volcano. Imagine a pizza oven cranked up to the absolute limit and you're still not close. And then there's Parker's speed. It's zooming through space at an astonishing 200 kilometers per second. At that speed, you could travel from New York to Tokyo in under a minute. But Parker isn't just about the thrill of speed or the resilience of its materials. It's about what it can tell us. The data it collects could revolutionize our understanding of stellar physics, revealing truths about the Sun that could one day transform how we harness energy, how we predict space weather, and even how we understand the origins of life itself. But Parker's mission isn't merely about science. It's about daring, courage, and the unyielding spirit of human ingenuity. Imagine plunging headfirst into the very furnace that fuels our solar system, knowing that the risks are unimaginable. But the rewards... oh, the rewards could be beyond anything we've ever dreamed. As Parker spirals closer and closer to the Sun, it sends back whispers from the very edge of our comprehension. Secrets that scientists and philosophers alike have longed to hear. What drives the Sun's power? What forces shape the cosmos? And what lessons can this burning giant teach us about our own existence? Picture the Parker Solar Probe, braving the Sun's fury to give us answers we've sought for centuries. It's not just metal and circuits. It's a testament to the insatiable curiosity that defines us as a species. Think of all the unknowns, all the boundaries we've crossed just to get a glimpse of the mysteries beyond. If Parker can endure the sun's blistering heat, if it can journey to the edge of human possibility just to quench our thirst for knowledge, what limits would you push to discover the unknown? Would you face your fears, challenge the boundaries of what's possible, and reach for the stars? Our journey with Parker is just beginning. We're standing at the threshold of the sun's domain, ready to uncover the mysteries that have eluded us for so long. It's a story of fire, courage, and the relentless pursuit of knowledge. And as we follow Parker on its daring path, we are reminded that sometimes the answers we seek lie not in the calm and predictable, but in the heart of the storm, in the furnace of the cosmos itself. The sun's corona is a place of profound mystery, a chaotic expanse of superheated plasma and magnetic fields that defy easy explanation. As Parker pushes ever closer, it's not just the data it's collecting that matters, it's the inspiration it brings to everyone who watches. We are voyaging into a part of our solar system that has been unreachable for all of human history. Just a few decades ago, the idea of touching the sun seemed like a dream, an impossible feat of science fiction. Yet here we are, on the cusp of discoveries that could change everything we know about how stars work, how they age, and how they interact with the space around them. Think about the implications of understanding the sun at this level. The sun's influence reaches far beyond the planets it warms. Solar storms have the potential to disrupt technology, power grids, and communication systems here on Earth. By understanding the fundamental mechanics of solar activity, we might be able to predict these events with more precision, safeguarding our technology-dependent world from potentially catastrophic disruptions. Parker is not just a probe, it's a guardian, helping us to foresee and prepare for the sun's more unpredictable moods. And let's not forget the sheer human determination that made this mission possible. The Parker Solar Probe represents the best of what humanity can achieve when we push ourselves to solve problems that seem insurmountable. The technology behind Parker's heat shield alone is a marvel, designed to withstand the sun's brutal heat while keeping the instruments inside at a comfortable temperature. It's a bit like holding an ice cube in the middle of a blazing inferno. Such technological feats remind us of our capacity for brilliance, of what can happen when scientists, engineers, and dreamers come together with a single purpose. The Parker Solar Probe's journey also symbolizes our unending quest to understand our place in the universe. The sun has always been more than just a star. It's been a symbol, a source of life, a deity in many cultures, and the heart of our solar system. By daring to reach for it, we are, in a way, seeking to understand ourselves. What makes life possible? What are the forces that shape the environments we call home? And as we look towards the sun, we are reminded of its power, beauty, and the essential role it plays in the grand cosmic ballet. As Parker sends back its data, we eagerly anticipate each new piece of information, each new whisper from the sun that brings us closer to answers. We know that with each pass, Parker will venture deeper, revealing more about the mysterious dynamics of the corona, the magnetic fields, and the source of solar winds that reach far into the cosmos. This mission is not just an adventure, it's a turning point, a critical chapter in our journey to understand the universe around us. So here's the question. Are you ready to take that leap? To dive into the heart of our star and discover what secrets lie within? Because this journey isn't just about Parker, it's about all of us. Our quest to understand our place in the universe and the daring steps we take to get there. The sun may be a distant, untouchable force, but with Parker, we're making the impossible possible, one fiery pass at a time. Mercury, the scorched enigma. Mercury, a world so unforgiving, so extreme that it almost defies reality. A place where contradictions reign and fire and ice collide in a cosmic battleground. A planet of paradoxes, secrets, and raw power, where nature's most relentless forces clash in an endless struggle for dominance. If you thought Parker's mission to the sun was intense, Just wait until we journey to Mercury, the smallest, yet one of the most intriguing planets in our solar system. Mercury isn't just a story of searing heat. It's a tale of relentless extremes, of silent nights colder than the deepest void, juxtaposed with days bathed in scorching, relentless sunlight. It's a cosmic enigma, a riddle written across ancient, cratered plains and towering, fractured cliffs. Mercury dares us to uncover its secrets, to decipher the delicate balance of forces that allows it to exist against all odds. It is a world that defies expectation, that laughs in the face of simplicity. So brace yourself, for what you're about to experience isn't just a journey. It's an exploration of the most enigmatic of planetary realms, a place that challenges everything we think we know about the universe. This is Mercury, the battleground of cosmic extremes, where the mysteries run deeper than you could ever imagine. Mercury, a planet of extremes. Mercury is a land of extremes in every possible way. Its sunlit side reaches an unimaginable 427 degrees Celsius, hot enough to melt lead. But don't be fooled. On the shadowed side, temperatures plummet to a bone-chilling 193 degrees Celsius. One world, two extremes. But how can Mercury embody such drastic contradictions? The secret lies in its incredibly thin atmosphere, or rather, its lack of one. Mercury's atmosphere is so tenuous that it cannot trap heat, leading to an extraordinary split between day and night temperatures, a chasm of unbearable contrast that separates light from darkness. Mercury's lack of atmosphere also means it's constantly exposed to space weather, with solar winds bombarding its surface and creating dynamic interactions that are still not fully understood. This intense exposure has led to a planetary surface that is not only scarred by impacts, but also shaped by the relentless bombardment of particles from the sun. To make matters even more fascinating, Mercury is a dense little world. Despite being only 38% the size of Earth, it packs a punch in terms of mass, holding a massive metallic core that accounts for an incredible 57% of its volume. Imagine peeling an orange only to find that most of it is made of the seed. That's Mercury, a planet with an oversized heart of iron. Scientists believe this dense iron core holds clues to the planet's violent history. Was Mercury once a much larger world, stripped down by cataclysmic collisions in the early solar system? The idea that Mercury was once far larger, reduced to its iron essence by devastating impacts, adds a whole new layer of drama to its story. The core itself is mysterious. Why is it so large relative to the planet's overall size? Some scientists theorize that early in the solar system's history, Mercury may have suffered massive collisions that blasted away much of its original rocky mantle, leaving behind a disproportionately large core. This scenario paints Mercury as a survivor of cataclysmic events, a tiny world that has faced and withstood unimaginable cosmic violence. Understanding Mercury's core can provide valuable insights not only into its own history, but also into the processes that shape planets in general, including Earth. A landscape shaped by chaos. But Mercury isn't just about numbers and science. It's a cosmic canvas painted by chaos. Its surface is scarred by countless craters, each one telling a story of impacts from space rocks over billions of years. The most impressive of these is Caloris Planitia, a gigantic impact basin spanning 1,550 kilometers across. Picture an asteroid the size of Manhattan colliding with a young, molten Mercury. The resulting explosion was so colossal that it reshaped the planet's crust, leaving behind a scar that can be seen from space. And it doesn't stop there. At the heart of this impact zone lies one of the most puzzling and visually stunning features in the solar system: Pantheon Fossae. That Pantheon Fossae looks like something straight out of a sci-fi movie, a radial web of cracks extending outward like the rays of a cosmic sunburst. The origin of this bizarre formation has puzzled scientists for years. Was it caused by tectonic forces? Or did the cooling and shrinking of Mercury literally crack its surface, like mud drying under the heat of the sun? No one knows for sure, but one thing is certain: Mercury's surface is a vivid reminder of the dynamic, ever-changing nature of our solar system. It's a place where every crater and ridge has a story to tell, an ancient record of cosmic violence and geological change. Mercury's surface also features cliffs, known as scarps, that stretch for hundreds of kilometers and rise up to a mile high. These scarps are thought to have formed as the planet cooled and contracted, causing the crust to buckle. Imagine an entire world slowly shrinking, its surface crumpling like a raisin. This planetary shrinkage is another clue to the complex and dynamic history of Mercury, a planet that has evolved in ways that are still not completely understood. Fire and ice, the contradictions of Mercury. And then comes one of the biggest surprises Mercury has to offer: ice. Yes, ice on the closest planet to the Sun. In the perpetually shadowed craters near Mercury's poles, temperatures remain frigid, never rising above 200 degrees Celsius. Here, water ice has survived for millions, possibly billions of years, shielded by layers of insulating dust. The very idea that ice can exist mere kilometers away from plains that bake at 600 degrees hotter is mind-boggling. Mercury is a land of juxtapositions, a planet where the extremes of fire and ice coexist in stark contrast, where searing heat and bone-chilling cold are only a short distance apart. The presence of ice on Mercury raises fascinating questions about the origins of water in the solar system. How did the ice get there? Some scientists believe it may have been delivered by comets or asteroids, while others suggest it could have formed from interactions between the solar wind and the surface. Regardless of its origin, the discovery of ice on Mercury challenges our assumptions about what is possible on a planet so close to the Sun and suggests that even the most inhospitable environments may harbor surprising secrets. An enigmatic neighbor. Despite being our closest planetary neighbor, Mercury has long remained an enigma. For centuries, ancient astronomers mistook it for two separate stars because of its changing position relative to the Sun. Even today, observing Mercury is a challenging feat due to its proximity to our star, often lost in the Sun's blinding glare. It wasn't until the 1970s, when NASA's Mariner 10 flew by, that we finally got our first close-up look. Mariner 10 revealed Mercury's stark, cratered landscape and hinted at some fascinating secrets, like the presence of a weak magnetic field, something no one expected from such a small planet. Mercury's magnetic field is another of its many puzzles. Unlike Venus, Mars, or the Moon, Mercury has a magnetic field, albeit one that is only about 1% as strong as Earth's. The presence of this field suggests that Mercury's core is at least partially molten, creating a dynamo effect similar to the one that generates Earth's magnetic field. Understanding how Mercury, a planet so small and seemingly inactive, can maintain a magnetic field offers insights into the conditions needed for planetary dynamos and helps us understand more about the magnetic histories of other planets. Unveiling Mercury's secrets. Fast forward to 2011, and NASA's Messenger spacecraft became the first to orbit Mercury, mapping nearly every inch of its surface and uncovering new layers to its mystery. Messenger's discoveries were astonishing. Evidence of past volcanic activity, strange hollows dotting its surface, and a mysterious interaction between Mercury's magnetic field and the solar wind. These findings gave us a glimpse of Mercury's past, a world that was once geologically active, shaped by eruptions and cataclysmic impacts. The volcanic plains of Mercury tell the story of a world that once had flowing lava, a far cry from the barren, rocky surface we see today. But as with all good mysteries, the more we learned, the more questions arose. Now we're on the edge of yet another chapter in Mercury's exploration with the arrival of Bepi Colombo, a joint mission by the European Space Agency and Japan. Scheduled to enter Mercury's orbit by 2025, Bepi Colombo promises to dive even deeper into the mysteries of this scorched world, exploring its magnetic field, its thin exosphere, and the secrets hidden in its rocks. What will Bepi Colombo reveal? Will it solve the puzzle of Pantheon Fosse, or uncover new mysteries that will keep us guessing for years to come? Perhaps we will finally understand the processes that shaped Mercury's unusual landscape, or get definitive answers about its magnetic field and core. The scorched enigma, more than meets the eye. Mercury may be small, but its story is anything but. It's a world of fire and ice, of ancient impacts and hidden water, of colossal forces and razor-thin atmospheres. It's a planet that challenges our understanding of what it means to be part of the solar system, a place that holds surprises at every turn. And here's a thought to leave you with. If we can find ice in the shadows of Mercury, a planet scorched by its proximity to the Sun, what other surprises might be lurking in the seemingly uninhabitable corners of our solar system? What do you think? Share your thoughts in the comments below. Perhaps the harshest places are where we'll find the most profound answers. Mercury, the scorched enigma, invites us to question, to explore, and to wonder. It's a reminder that even the smallest worlds can hold the biggest secrets, and that the more we learn about our cosmic neighborhood, the more we realize just how much more there is left to discover. Mercury's extremes and contradictions reflect the complexity of the universe itself, a place where, even in the harshest conditions, beauty, mystery, and wonder await those who dare to look closer. Venus, the veiled inferno. If Mercury's tale of fire and ice piqued your curiosity, Venus will turn up the heat and then some. Often called Earth's twin due to its similar size and rocky composition, Venus couldn't be more different when you venture beneath its thick, mysterious atmosphere. This isn't just any planetary story. It's a cosmic paradox. Let's peel back the dense, toxic clouds and uncover a world so hostile it seems to defy the laws of nature. Where conditions are so extreme, it's almost as if the universe itself wanted to create a celestial challenge. The hostile surface of Venus. Venus orbits the Sun at a cozy distance of 0.72 astronomical units, well within what's called the habitable zone. But don't let those numbers fool you. Venus is anything but habitable. Its surface temperature averages an unbearable 464 degrees Celsius, hot enough to melt lead without breaking a sweat. Imagine standing on a world where the heat never lets up, and the ground beneath you is so scorched, even metals would ooze like wax in the blistering oven-like conditions. The relentless heat radiating from every direction creates an environment where survival is simply impossible. And then there's the atmosphere. With a pressure 93 times that of Earth's, it's like being submerged nearly a kilometer beneath the ocean. Anything that dares to land on Venus is not just melted. It's crushed, incinerated, and obliterated in one of the most inhospitable places in our solar system. Picture the harshest conditions imaginable. Venus takes that, amplifies it, and then adds a dense, toxic shroud of sulfuric acid clouds for good measure. These clouds don't just block our view. They actively participate in the planet's hostile nature, raining down corrosive acid that would dissolve most materials within minutes. Venus is a planetary pressure cooker that leaves no chance for survival. A temperate past? But here's where it gets truly fascinating. Venus wasn't always the hellish landscape we see today. Billions of years ago, it might have been far more Earth-like, with vast oceans of liquid water and a temperate climate that could have supported life. Imagine a young Venus, its surface shimmering with oceans, its skies filled with wispy clouds, not unlike our own world. So, what turned this promising twin into a planetary nightmare? Enter the runaway greenhouse effect. As the Sun grew hotter over time, Venus's carbon dioxide-rich atmosphere began trapping more and more heat. This created a vicious feedback loop. Temperatures rose, oceans boiled away, and the water vapor, a potent greenhouse gas, trapped even more heat. Eventually, all the water was lost, and Venus was left with a thick, toxic blanket of clouds, transforming into the inferno we know today. The concept of a runaway greenhouse effect is both fascinating and terrifying. It shows just how delicate the balance of a planetary climate can be, and how easily things can spiral out of control. Venus's transformation serves as a cautionary tale. a glimpse of what might await any world that cannot regulate its atmospheric conditions. It's a stark reminder of how quickly paradise can turn into perdition. The mysterious veil of clouds. These clouds, made primarily of sulfuric acid, act like a shroud, hiding Venus's surface from view. For centuries, their opacity led to wild speculation about what lay beneath. Early astronomers imagined lush, tropical jungles teeming with alien life. Science fiction writers dreamed of Venusian civilizations, advanced and mysterious. The truth, however, turned out to be far more shocking. A hellscape of volcanic plains and mountainous terrain, revealed only after radar mapping finally pierced through the clouds. The Magellan spacecraft, which orbited Venus from 1990 to 1994, gave us our first real glimpse beneath the veil. One of its most remarkable discoveries was the vast highland region called Aphrodite Terra. Spanning an area comparable to the size of Asia, this colossal continent features towering mountains, deep crevices, and abundant evidence of volcanic activity. At its heart lies Mat Mons, a massive shield volcano that may have erupted relatively recently, at least in geological terms. Could Venus still be geologically active? Many scientists believe the answer is yes, and if true, it could reshape our understanding of volcanic activity on other planets. The idea of geological activity on Venus is tantalizing. Active volcanoes could mean that Venus is not just a dead rock drifting through space, but a dynamic world with forces still shaping its surface. Imagine rivers of molten lava flowing across the landscape, reshaping it even now. The thought that a planet as hostile as Venus might still be evolving adds another layer of intrigue to this mysterious world. Alien landscapes and snowy peaks. And then there's Ishtar Terra, another prominent highland region, crowned by Maxwell Montes, the tallest mountain on Venus. Rising 11 kilometers above the average surface level, Maxwell Montes stands as a testament to the extreme geological forces at play on this planet. Its peaks even glisten in radar images, likely due to metallic compounds that condense at high altitudes. Venusian snow, if you will. It's eerie, it's beautiful, and it's a haunting reminder of the alien chemistry at work in this brutal world. Picture the stark contrast. Towering peaks covered in metallic frost, rising above a landscape of unimaginable heat and pressure. It's almost poetic, the idea that even in the most hostile places, beauty can still emerge. Maxwell Montes and its glistening peaks are a striking reminder that Venus, while terrifying, is also strangely captivating. Mysteries of the atmosphere. But Venus's story doesn't end at its surface. Its atmosphere is filled with mysteries that tantalize scientists to this day. At higher altitudes, where temperatures and pressures are more akin to those on Earth, there exists a narrow region that some theorize could harbor microbial life. In 2020, the detection of phosphine gas, a potential biosignature, sparked intense debate and worldwide interest. Could there be life, even microbial, in the clouds of Venus? While subsequent studies questioned the initial findings, the idea that life might exist in the Venusian atmosphere remains an enthralling possibility. The notion that in the midst of this toxic, crushing atmosphere, there could be pockets where life has found a way is a powerful reminder of the resilience of life itself. Imagine microscopic organisms drifting through the clouds of Venus, thriving in an environment that would destroy most forms of life. It's a compelling image, a testament to the adaptability of life and the possibility that it can exist in the most unexpected places. If life can survive on Venus, even in such extreme conditions, it raises the question, where else might we find life in our universe? The missing magnetic shield. Another crucial piece of the Venus puzzle is its lack of a strong magnetic field. Unlike Earth, which has a protective magnetosphere to shield us from the sun's solar wind, Venus lacks this essential defense. As a result, the solar wind has slowly but steadily stripped away lighter elements like hydrogen from the planet's atmosphere, contributing to the complete loss of its ancient oceans. It's a stark reminder of just how important a magnetic field is for planetary habitability. Without it, a planet is vulnerable, defenseless against the harsh realities of space. The absence of a magnetic field on Venus is not just a scientific curiosity, it's a critical factor that shaped the planet's fate. Without that protective shield, Venus was laid bare to the fury of the sun. Its atmosphere was eroded, its water was lost, and the planet was left to bake under the relentless heat. It's a scenario that underscores the delicate balance required for a planet to remain habitable. The allure of Venus. Despite these challenges, Venus continues to beckon us. In recent years, new missions have been planned to explore this enigmatic planet in greater detail. The European Space Agency's Envision and NASA's Veritas missions are set to provide new insights into Venus's geologic history and atmospheric dynamics. Will these missions confirm that Venus is still geologically active? Could they uncover signs of ancient oceans that once shimmered under a younger sun? Or perhaps, just perhaps, find signs of life clinging to the clouds? Venus is a paradox, a place of immense heat and pressure, of death and destruction, yet also a world that might hold crucial answers about the past and even the future of our own planet. Venus is a world that challenges us to look beyond its inhospitable surface and see the possibilities hidden within. Each mission we send is a step closer to understanding not only Venus, but also the broader story of our solar system. What happened to Venus could, under different circumstances, happen to Earth. By studying Venus, we gain insights into how planets evolve, how climates change, and what factors can lead to a world becoming uninhabitable. It's a quest for knowledge that has profound implications for our understanding of Earth's own future. What if Earth had taken a different path? As we leave Venus behind, one question lingers. What if Earth had suffered the same fate? Could our blue planet have turned into a second Venus if circumstances had been just slightly different? It's a sobering thought. Venus serves as a stark warning, a reminder of what could happen when greenhouse gases run wild, when balance is lost, and when a planet's natural defenses falter. It's a glimpse into an alternate future for Earth, one that we must strive to avoid. Imagine an alternate history where Earth's atmosphere became thick with carbon dioxide, where our oceans evaporated, and where temperatures soared to unbearable levels. It's a chilling vision, but one that underscores the importance of maintaining the delicate balance of our environment. Venus is a warning, a message from our cosmic twin about the dangers of unchecked greenhouse effects and the fragility of planetary habitability. The bigger picture. Ultimately, Venus is not just a story of a planet gone wrong. It's a cautionary tale and a fascinating mystery all wrapped into one. It challenges our understanding of planetary science, pushes us to consider our place in the solar system, and compels us to think about the fragile balance that makes life on Earth possible. As we continue our journey through the cosmos, Venus remains a key chapter in the unfolding story of our quest for knowledge, a fiery enigma that refuses to be ignored. The story of Venus is a reminder that our universe is full of wonders and dangers. It's a place where planets can flourish or fail, where the conditions for life can be created or destroyed. Venus, with all its extremes, stands as both a symbol of what might have been and a warning of what could still happen. It's a world that beckons us to learn, to explore, and to understand the forces that shape not only distant planets, but our own fragile world as well. Earth, the jewel in the cosmic crown. Earth, our fragile oasis suspended in the vastness of space. It's easy to take this blue and green marble for granted, but beneath its familiar sky lies a story of resilience and wonder. Earth is not just our home, it's a sanctuary, a cradle of life nurtured against improbable odds. Where other planets are barren, Earth breathes. Where the cosmos is silent, Earth sings. Its oceans roar, its winds whisper, its forests murmur with the intricate dance of life. Here, amidst the chaos of the universe, Earth is a sanctuary of warmth, water, and light. But it is also a delicate balance, a fleeting moment in cosmic history where conditions aligned perfectly for life to emerge and flourish. Each sunrise, each wave breaking against the shore, each leaf unfolding in the spring, all are part of a fragile miracle that could so easily have never been. Earth reminds us that in a universe indifferent to life, we are the exception, a rare, precious miracle that must be cherished. A fiery birth and the long road to life. The story of Earth begins over 4.5 billion years ago, when it was nothing more than a swirling mass of molten rock and metal, colliding fragments from the chaos of the early solar system. It was a world ablaze, where the concept of life was as alien as the farthest galaxy. Violent impacts shaped its surface, and volcanic eruptions spewed lava and gas into the forming atmosphere. A toxic cocktail of water vapor, carbon dioxide, and nitrogen. But amid this tumultuous scene, Earth began its slow, miraculous transformation. Over millions of years, the planet cooled, allowing a thin crust to form. As temperatures dropped, rains began to fall, torrents that filled Earth's basins, giving birth to oceans. Imagine the scene. The very first rainfall after eons of fire, the hiss of steam rising as water met hot rock. The skies darkened with thunderclouds, and the once fiery surface was transformed into a world where water carved new landscapes, creating oceans, rivers, and lakes. And with these oceans, the first whispers of life began. Small, single-celled organisms emerged, tiny pioneers on a young planet with no guarantee of survival. Yet they thrived, slowly setting the stage for what was to come. These early organisms were the foundation upon which the extraordinary diversity of life would be built. The Goldilocks zone and the shield of life. Earth's position in the Goldilocks zone, not too hot, not too cold, allowed liquid water to persist, a critical ingredient for life as we know it. But what truly set Earth apart was an unsung hero, its magnetic field. Generated by the planet's molten iron core, this invisible shield deflected harmful solar radiation, protecting Earth from the solar wind that strips atmospheres away. Imagine solar flares bombarding the planet, particles capable of eroding the atmosphere and sterilizing the surface. Without our magnetic shield, Earth would have been just another barren rock drifting in space. It's a luxury that Venus lacks and Mars tragically lost. A reminder of how finely balanced the conditions for life are, and how our planet seems almost improbably lucky in its perfection. From microscopic beginnings to the Cambrian explosion. Fast forward a few billion years, and life on Earth had evolved from simple single-celled organisms into complex multicellular forms. The Cambrian explosion, which began around 541 million years ago, was a true turning point. A sudden surge in the diversity of life that filled Earth's oceans with strange and astonishing creatures. Imagine an ocean teeming with bizarre life forms, some covered in spikes, others with countless eyes, creatures that seem almost alien by today's standards. It was as if nature had suddenly discovered creativity, and Earth became a laboratory for the wonders of evolution. This explosion of life wasn't just a biological event. It was the start of complex ecosystems, of predator and prey, of collaboration and competition, a vibrant tapestry of interactions that would lay the groundwork for everything to come. Catastrophes and new beginnings. But life's journey was anything but smooth. Earth endured mass extinctions, cataclysms that wiped out entire lineages. From the Permian-Triassic event that obliterated 96% of marine species, to the asteroid impact that ended the reign of the dinosaurs 66 million years ago, Earth was shaped as much by destruction as it was by creation. Picture the devastation, a fiery inferno that spread across continents, skies darkened by dust, and entire ecosystems collapsing. Each catastrophe was both an ending and a new beginning. Without that asteroid, mammals, and eventually humans, might never have risen to prominence. It's a humbling thought. Our existence is built on the back of countless lost worlds. Each mass extinction cleared the way for new forms of life to evolve, making room for creatures that would dominate the next era. The rise of humanity. And then there's us, humans. In the grand timeline of Earth's history, our species has been around for just a blink of an eye. Yet, in that fleeting moment, we have reshaped the planet in profound ways. From the Industrial Revolution to the digital age, our impact on the world is undeniable. We have moved mountains, redirected rivers, and transformed landscapes. We've built sprawling cities that can be seen from space and harnessed the power of atoms. We have even begun to explore the very fabric of reality, seeking answers to the most profound questions about existence. Do you know what role you play in preserving our planet's delicate balance? Yet still in our quest for progress, Earth serves as a constant reminder. It is the only home we have, and its delicate balance is something we cannot afford to take for granted. Our ingenuity has propelled us to incredible heights, but with that power comes responsibility. A duty to preserve the planet that has given us everything. A tapestry of natural wonders. Earth's surface is a canvas of incredible diversity, a masterpiece of nature painted over billions of years. Picture the towering Himalayas, carved by the relentless movement of tectonic plates, standing as a testament to Earth's restless energy. Imagine the vast, shimmering sands of the Sahara Desert, where winds sculpt dunes into waves of gold, creating an ever-changing landscape of beauty and desolation. Visualize the lush, dense Amazon rainforest, teeming with life at every turn, an ecosystem so vibrant that its mere existence supports the entire planet. The Amazon is a heartbeat of Earth, producing oxygen, regulating the climate, and harboring untold species. Each landscape tells a story, shaped by geological forces and biological evolution, each as magnificent as it is fragile. Earth is a dynamic living planet, constantly evolving, where every ecosystem plays a crucial role in the intricate web of life. The atmosphere. Earth's fragile blanket. Above us lies Earth's atmosphere, a delicate blend of nitrogen, oxygen, and trace gases that sustains life. It's our protective blanket, shielding us from harmful solar radiation and regulating the planet's temperature, making sure that Earth remains habitable. But this balance is fragile. Human activities, from burning fossil fuels to deforestation, have thrown this equilibrium into jeopardy. Some people still deny the impact of human actions on our planet, but the evidence is undeniable. Do you know what specific actions you can take to reduce your carbon footprint? Share your thoughts in the comments. Climate change is a stark reminder of just how interconnected everything on Earth is. The air we breathe, the water we drink, the land we cultivate, all are part of a system that, if disturbed, can have cascading effects. Imagine the atmosphere as a finely tuned instrument. One small adjustment can throw the entire melody out of tune. Rising temperatures, melting ice caps, and shifting weather patterns are signals that we must listen to. Warnings that the delicate harmony sustaining life is at risk. It is a call to action, a plea for stewardship of the only home we have. Earth, the benchmark of life. As we look beyond, dreaming of colonizing Mars or discovering Earth-like exoplanets light years away, our own planet stands as the ultimate benchmark. What makes Earth so special? Is it the magnetic field that shields us, the water that sustains us, or the atmosphere that nurtures us? Or is it the sheer improbability of all these factors aligning perfectly to create a cradle for life? Perhaps it's all of these things, working in harmony, that make Earth a miracle, a jewel in the vast expanse of the cosmos. It is the standard by which we measure all other worlds, the blueprint for what a habitable planet should be. And as we search the stars for signs of life, Earth remains the example of what is possible when everything goes just right. Yet, even as we celebrate Earth's uniqueness, its story serves as a cautionary tale. The delicate balance that sustains life can be disrupted. by nature, or by our own actions. If Venus is a warning of what a runaway greenhouse effect can do, Earth is a reminder of what we stand to lose and what we must strive to protect. It is both a sanctuary and a fragile gift, and it's up to us to safeguard its future. The stakes could not be higher. The story of Venus shows us a world that lost its way, a planet once possibly like Earth that became a hostile inferno. Our choices today will determine whether we continue to thrive or follow a similar path to devastation. Are you ready to continue our adventure into the unknown, to explore a world that may hold the answers to some of our deepest questions? Let us embark on the next chapter of our cosmic journey, together. The Jurassic Period, an era of flourishing giants. Step into an ancient world where giants roamed and wonders thrived. A world so vibrant and untamed that it feels like the setting of an epic tale. The Jurassic Period, beginning around 2.1 million years ago, was a time of staggering transformation and endless possibility. Picture Earth not as we know it now, but as a realm in flux, with colossal landmasses breaking apart, giving birth to new oceans and landscapes. The supercontinent Pangaea was shattering, fragmenting into pieces that would one day become the continents we call home. This massive upheaval forged shallow seas and new coastlines, creating an intricate tapestry of isolated worlds, each one a hotbed of wild, unpredictable evolution. Here, life flourished with incredible diversity, from towering dinosaurs to lush fern forests, all in a time when nature was free to dream big and rewrite the rules. This was the Jurassic, an age of wonder, change, and life unbounded, where Earth itself seemed to breathe, grow, and set the stage for the incredible journey of life that continues to this day. The climate during the Jurassic was predominantly warm and humid, a veritable paradise for life to thrive. Dense tropical forests covered the land, filled with towering cycads and gymnosperms that resembled today's palm trees, while conifers like the early cypress and pine painted a lush green landscape. It was a vibrant primeval world, one where the air was thick with the scent of prehistoric foliage, and the horizon was dotted with silhouettes of giants that ruled the land with their immense presence. Among these giants, the age of dinosaurs reached its zenith. Imagine the ground shaking beneath your feet as sauropods, gentle herbivorous behemoths like Brachiosaurus, Brontosaurus, and Diplodocus, roamed the forests. These titanic creatures, some reaching lengths of over 30 meters and weighing more than 75 tons, were nature's most astonishing marvels. With their impossibly long necks, they grazed on the tops of the tallest trees, consuming vast quantities of vegetation. Evolution had endowed these giants with remarkable adaptations, such as their distinctive sacral brain, a widening in the hind vertebrae that may have housed a glycogen reserve, a biological necessity to fuel their massive bodies. Imagine having an auxiliary brain in your lower back, just to manage the enormous physical demands of such a colossal being. Some scientists believe that these giants may have been too large and unwieldy to survive without constantly eating, a theory that raises the question, was their size a grand success of evolution or an eventual path to extinction? Do you know how such massive creatures managed to survive in a world of limited resources? Share your thoughts in the comments below. But the Jurassic wasn't only about these awe-inspiring giants. Far beneath the towering dinosaurs, mammals, reptiles, and arthropods were quietly carving out their own niches in this lush world. They may have lived in the shadows of the dinosaurs, but they were no less important to the intricate web of life. Small mammals scurried through the underbrush, their nocturnal lifestyles helping them avoid the watchful eyes of the massive reptiles that dominated the daylight hours. These early mammals were the seeds of evolution that would one day grow into the diverse forms we see today, their adaptability laying the foundation for future success. In the oceans, the story was no less extraordinary. Bivalve mollusks thrived in these ancient seas, their shells opening and closing in the gentle sway of underwater currents. while ancient corals built intricate reef structures that provided shelter for countless marine creatures. But lurking in the deeper waters were the true apex predators of the Jurassic oceans, marine saurians like ichthyosaurs and pliosaurs. These incredible creatures were perfectly adapted for life in the water, with sleek, streamlined bodies and powerful tails that propelled them through the depths, embodying both strength and grace. The sight of an ichthyosaur gliding through the water would have been akin to watching a dolphin today, graceful, swift, and utterly captivating. One of the most fascinating inhabitants of these ancient seas was Ophthalmosaurus, a marine marvel that epitomized the evolutionary ingenuity of the time. Imagine a creature with a streamlined body and a crescent-shaped tail, diving to depths of 600 meters and holding its breath for up to 20 minutes. Its eyes, a staggering 10 centimeters wide, were protected by bony rings, allowing it to see in the dark, cold waters of the deep ocean. Its primary diet consisted of mollusks like squid, and in its nocturnal hunts, it served as a reminder of the interconnectedness of Jurassic ecosystems. Every aspect of life during this period was intertwined. Each predator, each prey, each plant played a role in a grand, harmonious design. The oceans were alive with movement, each ripple carrying the echoes of a thriving ecosystem. The evolutionary progress of the saurians during this time was nothing short of astounding. On land, theropods, the ancestors of today's birds, were beginning to show the first signs of feather development, evidence of evolution's slow but steady march towards greater complexity. The vibrant forests were filled with the calls of these creatures, their feathers perhaps used initially for display or insulation, hinting at a future where they would take to the skies. The Jurassic period was, in many ways, a time of experimentation, a grand trial where nature tested countless adaptations to find what worked best in this dynamic world. But as with every golden age, there comes a twilight. The Jurassic period, with all its grandeur, eventually gave way to the Cretaceous, an era of new beginnings, new challenges, and further transformation. As the curtain fell on Jurassic, the stage was set for the next chapter in Earth's prehistoric drama, a chapter that would see even more incredible developments in the story of life. The mighty sauropods and the first feathered dinosaurs were only the beginning. What lay ahead was a world of even more diversity, more wonder, and ultimately, more change. The Cretaceous, a prelude to the modern world. The Cretaceous period began around 145 million years ago, spanning an astonishing 79 million years, making it the longest period of the Mesozoic era. During this time, the continents continued their slow, relentless drift, gradually adopting the familiar outlines we see on our maps today. India began its journey northward towards Asia, while South America drifted westward, movements that would shape the future of our planet's geography. Imagine these land masses, colossal puzzle pieces, shifting inch by inch over millions of years, setting the stage for the world we live in today. The climate of the Cretaceous was cooler compared to the Jurassic, with fluctuations in temperature that had a profound impact on ecosystems. And with these changes came a quiet but revolutionary transformation. Flowering plants began to emerge, fundamentally altering the landscape. These plants, with their colorful blossoms and intricate reproductive strategies, heralded a new era of ecological diversity. Trees and grasses evolved, holding the soil in place, while seeds provided new food sources, spurring evolutionary leaps in both mammals and herbivorous dinosaurs. Imagine a landscape bursting with the first colorful flowers, brilliant hues breaking the monotony of green, attracting insects and creating new relationships that would fuel evolutionary innovation. These early blooms brought about an explosion of life, their bright colors drawing in pollinators, leading to complex symbiotic relationships that transformed ecosystems. Among the giants of the Cretaceous, Tyrannosaurus rex and Triceratops have become iconic symbols of prehistoric life, their images etched into our collective imagination. The massive bipedal T. rex, with its powerful jaws and keen sense of smell, was the apex predator of its time, while the horned and frilled Triceratops defended itself with sheer bulk and impressive horns. But the Cretaceous was so much more than just the age of the classic dinosaurs. Mammals were diversifying too, carving out their own spaces in this ever-changing world. Take Rapenomamus, for example, a meter-long 12 to 14 kilogram scavenger that challenged the notion that mammals were insignificant during the age of dinosaurs. Fossil evidence tells a vivid story. Remains of small dinosaurs have been found in its stomach, suggesting that these mammals were opportunistic predators, capable of taking advantage of any meal they could find. It's a glimpse into the fierce, cutthroat survival strategies that defined the time. Every creature fighting for its place in a competitive and unforgiving world. The oceans of the Cretaceous were no less dramatic. Majestic saurians like Mosasaurus and Plesiosaurus ruled the seas, powerful marine reptiles that dominated their watery domain. Mosasaurs, with their elongated bodies and powerful paddle-like limbs, were formidable hunters, while plesiosaurs, with their long necks and sleek forms, moved gracefully through the water, snapping up fish with their sharp teeth. However, even their supremacy was not to last forever. Around 95 million years ago, the Cenomanian-Turonian anoxic event struck, a global episode of oxygen depletion, likely triggered by massive underwater volcanic activity. The effects were catastrophic. Vast stretches of the ocean turned into dead zones, causing massive extinctions that reshaped marine ecosystems. The rulers of the Cretaceous seas found themselves struggling to survive, and many did not make it through this environmental upheaval. By the end of the Cretaceous, the world was entering one of its coldest phases in millions of years, a harsh reality that would test even the most adaptable of species. Dinosaurs like Nanotyrannus, a smaller cousin of the mighty T-Rex, roamed the colder regions of the Earth, showcasing remarkable resilience. These feathered creatures, with warm-blooded metabolisms, were adapted to survive the challenging Arctic conditions, their plumage providing insulation against the freezing temperatures. Imagine these agile hunters, moving through snowy landscapes, their feathers ruffled by the icy wind as they searched for prey. But even with these impressive adaptations, the looming shadow of extinction could not be escaped. The Cretaceous was a time of contrasts, of dazzling new life and catastrophic extinctions, of giants walking the earth and of delicate flowers blooming for the first time. It was a time that set the stage for the world that would come after, laying the groundwork for the rise of mammals and eventually the emergence of humanity. The final days of the dinosaurs played out against a backdrop of environmental upheaval and changing climates. But even as they faced their end, the seeds of a new world were being sown. A world that would, millions of years later, become our own. From the ashes of the giants rose the tiny, the adaptable, the resilient. Creatures that would go on to shape the future of life on Earth. The Cretaceous was not just an end. It was also a beginning, a prelude to the modern world that we now call home. The end of the Mesozoic, a cataclysmic transition. Picture a world ruled by colossal dinosaurs, where immense pterosaurs cast their shadows across the sky and the oceans churned with monstrous marine reptiles. This was Earth 66 million years ago, during the final moments of the Mesozoic era. It was a time of astonishing biodiversity, a world teeming with raw, untamed power. Every corner of the planet thrived, from lush, prehistoric jungles to sprawling plains dotted with herds of thunderous herbivores. Life was vibrant, and the balance of nature was an intricate dance of predators, prey, and unexpected alliances. A massive asteroid, hurtling through space at unimaginable speeds, made its devastating impact near what is now the Yucatan Peninsula. The moment when a blazing fireball cutting across the sky, followed by an earth-shattering explosion that would have lit up the horizon for thousands of miles. The collision released energy equivalent to billions of atomic bombs, creating a crater more than 150 kilometers wide. The ground trembled, the oceans heaved into towering tsunamis, and the sky darkened as clouds of ash, dust, and vapor were flung into the atmosphere. It was as if the very earth had declared war on its own inhabitants, a moment of cataclysm that no living creature could fully comprehend, leaving behind only whispers of a lost time. But here's something to consider. Could the asteroid impact alone have wiped out the dinosaurs? Or was there something more sinister at play? Perhaps a combination of forces conspiring against life on Earth? Do you know what other catastrophic events might have contributed to this mass extinction? The asteroid was only the beginning. Across the planet, volcanic activity erupted with furious intensity, sending plumes of molten lava and toxic gases into the air. The Deccan Traps in what is now India poured out vast quantities of lava, contributing to a planet-wide catastrophe that seemed almost apocalyptic. As firestorms raged and tsunamis roared, Earth fell into a nuclear winter-like state. Temperatures plummeted, sunlight was blocked for months, and ecosystems began to collapse under the weight of unrelenting disaster. It was an extinction-level event unlike anything the Earth had seen in millions of years. The Cretaceous-Paleogene extinction event was one of the most catastrophic episodes in Earth's history, wiping out approximately 75% of all species. The giants of the Mesozoic, non-avian dinosaurs, marine reptiles, and pterosaurs disappeared forever. Imagine a world where the once mighty Tyrannosaurus rex no longer roared, where the graceful pteranodon no longer soared above ancient forests. It was the end of an era marked by colossal life forms, thriving ecosystems, and the peak of reptilian dominance. The world grew silent as the giants fell, leaving behind only traces of their existence in the fossils buried beneath layers of rock and sediment. Yet, amidst this destruction, new opportunities emerged. The extinction of the dinosaurs opened the door for mammals and birds to step into the ecological void. Species that had once lived in the shadows of the dinosaurs began to evolve, diversify, and take on new roles. The Mesozoic's end was not merely a conclusion, it was a genesis, a prelude to the rise of the mammals, whose eventual dominance would shape the very world we live in today. With dinosaurs gone, mammals began to thrive, adapting to new environments, evolving into larger and more complex forms, and paving the way for a new chapter in Earth's evolutionary saga. It was a time of rebirth, where the smallest of creatures took on new roles, leading to the evolution of the vast and varied life forms we see today. This dramatic transition was also etched into Earth's geological layers, a vivid testament to the power of extinction and renewal. The iridium-rich layer found in rock strata around the world serves as a marker, a line that tells the story of that fateful day. Above it lies the story of life reborn, the rise of flowering plants, the spread of mammals, and the eventual evolution of primates. It was from this transformative era that our distant ancestors emerged, small and unassuming, but destined for greatness. The ashes of the Mesozoic gave birth to the foundations of the modern world. The Mesozoic's end wasn't just the end of an era of giants. It was the beginning of a new era of possibilities. It set the stage for the Cenozoic era, an era of mammals, birds, and ultimately, humanity itself. The story of Earth is one of resilience and adaptation, where each extinction paves the way for new life to rise. The Tharsis region, Mars' volcanic highlands. Now let's leave Earth behind and journey across the vastness of space to our neighboring planet, Mars. Picture a landscape unlike anything on our home world. A colossal volcanic plateau stretching across 1/4 of Mars's surface, a region known as Tharsis. This ancient landform is monumental, a staggering 30 million square kilometers, comparable to the size of the entire African continent. Rising 10 kilometers above the surrounding plains, the Tharsis region is not just a geological feature. It's a testament to Mars' tumultuous, fiery past. This is a land shaped by unimaginable forces, a relic of a time when Mars was alive with geological activity. Imagine standing on the edge of a volcanic caldera, the Martian wind whistling around you, the horizon dominated by the towering silhouette of Arsia Mons, one of the largest volcanoes in the solar system. Arsia Mons rises to an astonishing height of 19 kilometers, nearly 3 times taller than Mount Everest, with a caldera at its summit that stretches 110 kilometers wide. The sheer scale is mind-boggling. During Martian spring, when sunlight begins to warm its immense slopes, an awe-inspiring phenomenon occurs. Dust spirals into dense clouds, climbing up to 30 kilometers into the thin Martian atmosphere before dispersing across vast areas. It's as if Mars itself breathes in the warmth of the sun, releasing its ancient dust in a dance that speaks of its restless past. These swirling dust storms are more than just a spectacle. They are a reminder of the dynamic forces that continue to shape the red planet. But the wonders of Tharsis don't end with its massive volcanoes. Scattered across this region are vertical pits, likely the remnants of collapsed lava tubes, some with diameters reaching 150 meters and plunging to depths exceeding 178 meters. These yawning chasms are more than just geological curiosities. They are portals to the past, clues to the era when Mars was far more geologically active, and perhaps even more hospitable to life. Imagine the ancient lava flowing through these tubes, carving out caverns beneath the surface. Today, scientists wonder, could these collapsed tubes serve as natural shelters, protecting potential microbial life from Mars's harsh surface conditions? Could these underground worlds be the key to discovering whether life ever existed on Mars? There's another fascinating aspect to consider. Modeling suggests that during its prime, volcanic activity in Tharsis released enormous quantities of CO2 and water vapor into the atmosphere, enough to create an atmosphere 1.5 times as dense as Earth's today. This was a Mars that was warmer, wetter, and perhaps teeming with possibilities. A stark contrast to the cold, desolate environment we see now. Imagine rivers flowing across the Martian surface, lakes forming in craters, and a sky filled with clouds. The remnants of Tharsis tell the story of a planet that once had the potential to support life, a world where volcanoes sculpted the landscape and shaped the climate. It was a Mars that held promise, a world that might have been a cradle for life in its own unique way. Standing on Mars today, the Tharsis region might appear as a barren, rocky wasteland, but in its prime, it was a landscape of monumental forces, a place where the power of volcanic activity shaped not just the surface, but perhaps the fate of an entire world. It makes one wonder, what else lies hidden beneath the Martian soil? What secrets do these ancient volcanic highlands hold about Mars's past? And what could they tell us about its potential for the future? Could there still be traces of ancient life, frozen in time beneath the surface, waiting to be discovered by future explorers? As we continue our exploration of the red planet, we are not merely studying rocks and dust. We are peering back in time, unlocking the stories of a world that might have once been alive in ways we are only beginning to understand. Mars, with its colossal volcanoes and vast plains, invites us to dream about what once was and what might still be. Could Tharsis, with its towering peaks and ancient lava tubes, hold the key to understanding whether Mars once harbored life? Could it be that beneath the surface of this desolate world lies the evidence that life, even if only microbial, once thrived on our neighboring planet? The journey through Mars's volcanic highlands is not just a lesson in geology. It's a reminder of the dynamic forces that shape planets, both in our solar system and beyond. It's a testament to the mysteries of the cosmos that await us. Mysteries that beckon us to keep exploring, keep questioning, and keep reaching for the stars. As we stand on the edge of discovery, Mars challenges us to look beyond what we know, to imagine the possibilities that lie hidden beneath its surface, and to continue our quest to understand our place in the vast universe. The story of Mars is far from over. And as we push further into the cosmos, we may find that the red planet holds answers to questions we have yet to even ask. Valles Marineris, Mars's Grand Canyon. A scar stretches across the surface of Mars, so colossal it could swallow continents whole. A chasm that carves its way through a quarter of the planet. Moving east of the Tharsis volcanic region, we encounter one of Mars' most jaw-dropping features, the Valles Marineris. Spanning an astonishing 4,500 kilometers, it's not just any canyon. It's the largest canyon system in the entire solar system, and it dwarfs even Earth's Grand Canyon. Picture a rift that stretches nearly the entire length of the United States, a massive gash in the Martian landscape, with some parts plunging as deep as 11 kilometers. Its enormity defies comprehension. It's as if Mars itself has split open to reveal a hidden chapter of its ancient history. What stories do these monumental walls hold? What secrets are hidden in the cold Martian twilight? The dramatic landscape of Valles Marineris reveals a complex story etched in stone. A story of titanic forces, ancient waters, and cosmic upheavals. The steep, stratified slopes suggest that this massive canyon may have once cradled lakes and rivers. Each layer of rock is like a page in a book, offering precious clues about Mars' watery past. In the western and central regions, we see these layered deposits, sedimentary rocks that tell tales of time, water, and change. Here, Mars hints at what might have been. A planet once lush with flowing water, its canyons and valleys coursing with rivers. But as we move eastward, the terrain takes on an almost otherworldly complexity. The eastern stretches of Valles Marineris are a labyrinth, a chaotic, fractured landscape of canyons, plateaus, and deep, shadowy abysses. It is here that the planet's ancient chaos comes to life, where tectonic activity and erosion conspired to create one of the most enigmatic terrains in our solar system. Further north lies Chryse Planitia, where smooth plains mark the resting place of some of humanity's most ambitious Martian missions. The Viking 1 lander, which touched down in the 1970s, and the small Sojourner rover, part of the Pathfinder mission, made history here, sending back the first breathtaking images of the Martian surface, images that transported an entire generation to a new world. How did such a colossal feature come to exist? Scientists believe that Valles Marineris formed during Mars's early development, as tectonic forces began pulling and stretching the crust apart. Over time, erosion by wind and possibly water expanded and deepened the canyons, shaping them into the awe-inspiring landscape we see today. But there's more. Some theories suggest that Valles Marineris might even be linked to massive impacts on the opposite side of the planet. Consider the Utopia Planitia, a vast basin spanning 3,300 kilometers, likely formed by an ancient asteroid impact. This immense crater, scarred into the Martian surface, is believed to contain substantial underground water ice. Could the immense forces unleashed by such impacts have echoed across Mars, helping to create the epic rift that is Valles Marineris? It's a mystery that continues to captivate scientists, and a reminder of the incredible forces at work in shaping planets. To truly understand the grandeur of Valles Marineris, imagine standing at its edge, peering into the vast canyon stretching below. The sheer scale of the cliffs would dwarf anything seen on Earth. The air would be thin, the landscape alien and rugged. You could trace the lines of ancient waterways etched into the rocks, pathways carved by forces long gone. Dust devils might spiral up from the canyon floor, hinting at Mars's active and dynamic surface even today. Valles Marineris is not just a feature. It's a testament to the raw power of planetary geology, a reminder of the dramatic history that shaped Mars into the world we know now. Jezero Crater, a window to Mars' past. Standing at the edge of an ancient Martian lake, where gentle waves once caressed rocky shores and life might have flourished in secret lies, Jezero Crater, an unassuming basin on the western edge of Isidis Planitia, but also one of the most captivating destinations in our search for extraterrestrial life. Around 4 billion years ago, Jezero wasn't the barren, dust-choked crater we see today. It was alive with water, a vast lake fed by winding rivers brimming with possibility. As those rivers flowed, they carried minerals, nutrients, and whispers of potential life, leaving behind layers of sediment that could still contain the fossilized signatures of ancient microbial life, which now form a geological time capsule. What secrets do those rocks hold? Could they contain the fossilized remains of ancient Martian microbes, the first proof that life once existed beyond Earth? The story of Jezero Crater is one of mystery, hope, and a promise. A promise that some of Mars' deepest secrets may be waiting, just below the surface, for us to uncover. The Perseverance rover and its airborne companion, the Ingenuity helicopter, touched down in Jezero Crater in 2021, embarking on a mission that has already changed our understanding of Mars. Picture Perseverance slowly rolling across the Martian surface, its instruments trained on every rock and crevice, uncovering stories hidden for eons. The rover's mission is nothing short of revolutionary: to find traces of past life and determine whether Mars was ever habitable. Early in its exploration, Perseverance provided crucial evidence that the rocks at the bottom of Jezero were indeed in prolonged contact with liquid water, suggesting that this crater was once a thriving lake, rich with the chemical ingredients necessary for life. But what was Mars really like during this time? Scientists hypothesize that during the Hesperian epoch, a period that lasted from about 3.5 to 2.5 billion years ago, Mars had conditions that were strikingly similar to early Earth. Imagine a world with temperatures reaching up to 50 degrees C, with flowing rivers and lakes beneath a thick atmosphere. It was a time when the red planet might have had an environment warm and wet enough to sustain life. Jezero Crater, with its rich deposits of sediment, holds the key to unlocking this chapter of Martian history. Perseverance's mission, slated to last at least 14 years, is to search for signs of ancient microbial life and collect samples that could one day be returned to Earth. The rover's instruments are capable of examining rock textures and chemistry in detail, while Ingenuity scouts ahead, mapping terrain and exploring places that would otherwise be inaccessible. Jezero Crater is more than just a destination. It's a time capsule, a window into a period when Mars was perhaps not so different from Earth. If we can find even the faintest trace of ancient life here, it will fundamentally change our understanding of our place in the cosmos. Imagine what it would mean to hold a rock in your hand that contains evidence of Martian microbes, creatures that lived billions of years ago when Mars was warm, wet, and full of potential. The implications stretch far beyond Mars. They touch on questions of life itself, of how unique Earth is, and whether life is an inevitable outcome whenever the right conditions are present. To stand in Jezero Crater, even in our imagination, is to witness the remnants of a world that might have been alive. The dried riverbeds that snake across the crater floor are silent testimony to ancient forces at work. A planet that once had rivers, deltas, and perhaps even the spark of life. It's a humbling thought, one that brings into focus the fragile conditions necessary for life as we know it. The rover's exploration is a modern-day quest, a journey across time and space, driven by humanity's insatiable curiosity. Perseverance's exploration of Jezero Crater is a story that combines our enduring quest for knowledge with the incredible technology that makes such exploration possible. Every drill sample, every panoramic image, every sound recorded by the rover is a step closer to answering one of humanity's oldest questions. Are we alone? As Perseverance continues its journey, it is rewriting the history of Martian habitability, one rock at a time, and reminding us that the pursuit of knowledge is one of the noblest endeavors of humankind. And beyond that, what does it mean for us here on Earth? The search for life on Mars is not just about finding microbes on another planet. It's about understanding how common or rare life might be in the universe. If Mars, with all its similarities to early Earth, once harbored life, then it raises the likelihood that life could exist elsewhere. And if we find nothing, it makes our own existence all the more unique and precious. Jezero Crater represents a chapter in a much larger story, a story that ties together the fate of planets, the evolution of life, and the cosmic forces that shape them both. The excitement of exploration is palpable as Perseverance digs deeper, quite literally, into the Martian surface. Ingenuity, the small but mighty helicopter, hovers above, offering aerial perspectives that have never been seen before. Together, they make an incredible team. One on the ground, analyzing the past rock by rock, and the other soaring above, mapping the future. Their mission is a testament to human ingenuity and the unyielding desire to explore the unknown. As we follow perseverance and ingenuity on this journey, we are reminded that exploration is at the heart of the human spirit. We reach out into the darkness of space, not just to discover new worlds, but to better understand ourselves. Each discovery on Mars is a small piece of a grander puzzle, a clue that brings us closer to understanding the origins of life and our own place in the vast expanse of the universe. The adventure has only just begun, and who knows what secrets still lie beneath the rusty surface of Mars, waiting to be uncovered. The main asteroid belt. A solar system. Mosaic. Beyond the orbit of Mars lies a region unlike any other in our solar system. A sprawling, chaotic mosaic known as the main asteroid belt. Picture an endless gallery of over 1 million small celestial bodies, each uniquely sculpted by time and space. This belt stretches between 2.06 and 3.27 astronomical units, AU, from the Sun, where it floats as a living relic of the solar system's turbulent birth. When Ceres, the first asteroid, was discovered in 1801, a gateway to an unseen world opened, a place that has fascinated scientists as they search for the clues of how planets and moons came to be. The asteroid belt is a place of mystery, a chaotic zone filled with fragments of ancient worlds that never coalesced into a planet. It's a place where the remnants of failed beginnings tell a story of what might have been, a story of collisions, near misses, and the relentless pull of gravity that has kept these objects in an endless dance for billions of years. Here, we see a snapshot of the solar system as it was in its infancy, preserved in the rocky bodies that orbit between Mars and Jupiter. Each of these asteroids, from the smallest dust grain to the largest dwarf planet, holds a piece of the puzzle that could help us understand the birth of our planetary neighborhood. Ceres, the dwarf planet. Ceres, the largest object in this asteroid belt, is far more than just a chunk of rock floating in space. At a diameter of 940 kilometers, Ceres accounts for nearly a third of the asteroid belt's entire mass, making it a true giant among its neighbors. Beneath its dusty and cratered surface lies an icy mantle that is up to 100 kilometers thick, suggesting a significant reserve of water, one of the essential ingredients for life. Imagine, if you will, a vast underground ocean, frozen in time, holding secrets that stretch back to the dawn of the solar system. The average surface temperatures of Ceres dip to a chilling 106 degrees Celsius, but its story remains anything but cold. For astrobiologists, Ceres offers a tantalizing glimpse into what conditions might have been like when our solar system was still forming, and perhaps even hints at whether simple forms of life could have once taken root there. Could Ceres's potential for harboring ancient water be an indication that we have missed critical signs of life elsewhere in our solar system, all because of our Earth-centric biases? Do you know if scientists have truly explored all possibilities, or are they simply scratching the surface? The idea of an ancient frozen ocean beneath Ceres' surface sparks our imagination. What if, beneath its icy shell, there were pockets of liquid water, warmed by the slight geothermal heat that still lingers from its formation? Could microbial life have taken hold in these hidden reservoirs, thriving in the dark, nutrient-rich waters? It's questions like these that make Ceres a prime target for future missions. as we continue to explore the possibilities of life beyond Earth. Vesta, the shining beacon. Travel deeper into the belt, and you'll encounter Vesta, a bright beacon among the sea of celestial wanderers. Vesta is the second most massive object in the asteroid belt, and its surface gleams brightly, reflecting 42% of the sunlight that reaches it, making it a shimmering jewel against the dark backdrop of space. But beyond its brightness, Vesta's true allure lies in its dramatic landscape. The massive Rhea Silvia crater, spanning 500 kilometers in diameter, holds one of the tallest mountains in our solar system, a staggering 22 kilometers high, dwarfing even Mount Everest. It's a feature born of cosmic violence, a reminder of the turbulent forces that shaped the early solar system. Unlike many of its asteroid companions, Vesta has a complex, differentiated structure with a rocky mantle and a metallic core, much like a miniature planet. Studying Vesta allows scientists to peel back the layers of early planetary formation, understanding how rocky worlds like Earth might have come into existence. Vesta's story is one of survival against the odds. Its bright surface is scarred by impacts that tell of countless collisions, each one a testament to the dynamic and violent history of the asteroid belt. The Rhea Silvia crater is a scar from one such impact, a colossal event that nearly shattered Vesta entirely. Instead, Vesta endured, and from the debris of that collision, fragments were flung across space, some of which eventually fell to Earth, giving us a direct link to study this fascinating world. Holding a piece of Vesta in our hands is like holding a fragment of the solar system's history, a tangible connection to the forces that shaped our planetary home. Pallas and Silvia. Unique profiles. As we drift further into this cosmic mosaic, we come across Pallas and Silvia, two asteroids with unique stories to tell. Pallas, the third largest asteroid, has an unusual orbit that's tilted at 35 degrees, making it a challenge for any spacecraft hoping to pay a visit. Its surface is rich in silicates, hinting at a complex mineral history that might reveal more about the conditions of the early solar system. Pallas is a bit of an enigma, its tilted orbit suggesting that it may have been influenced by gravitational interactions or ancient collisions, events that have left it as a solitary wanderer, distinct from its neighbors. Meanwhile, Silvia is a different kind of wonder, what scientists call a rubble pile asteroid. Rather than being a single solid mass, Silvia is composed of loosely bound debris, a cosmic assembly of fragments that have come together over millennia. But Silvia's intrigue doesn't stop there. It has two small moons, Romulus and Remus, circling it. Imagine the intricate cosmic dance of these moons around their parent asteroid. A dance that speaks to a dynamic, collisional history, full of impacts and near misses. Silvia and its moons provide a snapshot of the delicate gravitational ballet that occurs in the asteroid belt, a reminder of the complex interactions that govern the motions of these celestial bodies. The asteroid belt, enigmatic and awe-inspiring, continues to guard its secrets closely. Missions like Dawn and Lucy are slowly unlocking these mysteries, revealing that even the smallest of celestial bodies can serve as time capsules, preserving the raw, primordial materials from which the planets themselves once formed. The asteroid belt is not just a collection of rocks. It is a library of the solar system's earliest chapters, waiting for us to read. Each asteroid tells a story of formation, destruction, and survival in the harsh environment of space. Europa and Ganymede, oceans beneath ice. As we journey further outward to the realm of Jupiter and its moons, the potential for extraterrestrial life gains new dimensions. Jupiter is orbited by dozens of moons, but among them, Europa and Ganymede stand out, not just because of their size or beauty, but because of the incredible secrets they hold beneath their icy surfaces. Imagine entire oceans, vast and alien, hidden under thick layers of ice. Oceans that could potentially harbor life forms unlike anything we've ever seen. It's within these moons that the dream of finding life beyond Earth takes on an exciting, almost tangible form. Europa, A hidden ocean. Beneath Europa's smooth, icy shell lies a secret. A hidden ocean that may hold more water than all of Earth's oceans combined. Europa's surface is crisscrossed with long fractures, giving it the appearance of a cracked eggshell. These fractures are not just marks on the surface. They are the visible evidence of powerful tidal forces exerted by Jupiter itself. These forces generate heat within Europa, preventing its ocean from freezing entirely. Imagine standing on Europa's surface, knowing that kilometers beneath your feet, an alien ocean teems in the dark, warmed by tidal flexing, perhaps with hydrothermal vents at its depths, vents similar to those on Earth where life thrives without sunlight. Could life be thriving there too, hidden away beneath an unbroken sheet of ice? It's this possibility that makes Europa one of the most intriguing places in our entire solar system, a world where the ingredients for life, water, energy, and chemistry might all be present. The prospect of life beneath Europa's ice is more than just a scientific hypothesis. It is a profound possibility that captures our imagination. If life can exist in the dark, cold depths of Europa, it would mean that life is far more resilient and widespread than we ever imagined. The Europa Clipper mission, set to launch soon, will bring us closer to answering these questions as it flies over Europa's surface, mapping the ice, studying the chemistry, and searching for signs that an alien ocean is hiding secrets just beneath the surface. Ganymede, the largest moon. If Europa is fascinating for its potential to harbor life, Ganymede is equally captivating for its sheer size and complexity. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury. But it's what lies beneath its icy crust that has scientists captivated. A multi-layered salty ocean, thought to be divided into different layers of varying salinity and temperature. Ganymede's ocean is separated by layers of ice, like a cosmic lasagna, hinting at an environment that is both complex and potentially full of surprises. Ganymede is also unique for having a liquid metal core, generating a magnetic field, the only moon known to have one. Imagine the auroras dancing across its surface, influenced both by its own magnetic field and by Jupiter's powerful magnetosphere. These auroras are more than just a beautiful spectacle. They are clues that help scientists understand the hidden processes at work within Ganymede. Ganymede's surface is peppered with carbon dioxide, sulfur dioxide, and other organic molecules, which might have originated from its hidden depths, delivered by upwelling plumes from its ocean. These signs point to a rich chemistry, one that scientists are eager to explore for any hints of habitability. The upcoming JUICE, Jupiter Icy Moons Explorer mission, aims to study Ganymede in greater detail, focusing on its magnetic field, its ocean, and the potential for life beneath its icy crust. Imagine the excitement of discovering complex organic molecules, or even signs of life, on a moon that orbits a giant gas planet over 500 million kilometers from the Sun, foreshadowing the journey ahead. The potential for life on Europa and Ganymede drives our curiosity beyond anything we've experienced before. Imagine what it would mean to discover life in these alien oceans. A second Genesis, completely independent from Earth. It would change everything we know about biology and our place in the universe. The upcoming missions, Europa Clipper and JUICE, are set to unravel these mysteries, to dive deeper, figuratively speaking, into these oceans and answer the burning question: could these icy worlds harbor alien life beneath their frozen exteriors? The journey of discovery in our solar system is a step-by-step unveiling of wonders, from the ancient relics of the asteroid belt to the hidden oceans of Jupiter's moons. Each step forward brings us closer to understanding not just the mechanics of how worlds are formed, but the profound question of whether or not we are alone. The answers might be out there, locked in the icy crusts of distant moons, or in the shimmering dust of asteroids, waiting for us to find them. Our exploration is far from over. With every mission, every probe, and every discovery, we piece together a cosmic puzzle, one that stretches across billions of kilometers and billions of years. And while we've come so far, the greatest revelations might still be waiting just beyond the horizon. As we look up at the night sky, we are reminded that the universe is vast and full of secrets, and it is our unyielding curiosity that drives us forward, step by step, into the unknown. The next chapter of our journey promises to be more wondrous than we can imagine. Callisto and the potential for extraterrestrial life. Among Jupiter's Galilean moons, Callisto stands as a silent enigma, a potential cradle for extraterrestrial life, despite its distant orbit and frozen landscape. Imagine a world almost as large as the planet Mercury, stretching 4,120 kilometers in diameter, but existing in the deep, cold shadow of Jupiter, where the sunlight barely reaches and temperatures plunge to the limits of habitability. Callisto's icy shell, an impenetrable barrier estimated to be 80 to 150 kilometers thick, hides a secret beneath its rugged surface, a vast subsurface ocean, whose depths range from 50 to 300 kilometers. Here, in the dark, frigid waters of Callisto, some scientists dare to wonder if life might find a way to thrive. This ocean is no ordinary body of water. Its temperature hovers around a chilly 251 Kelvin, 20 Fahrenheit. And yet, despite these cold conditions, impurities and the immense pressure from above ensure that this water remains liquid. It's an environment alien to anything on Earth. An ocean sealed beneath an unforgiving layer of ice with no sunlight to warm it, and a bedrock made of a frozen rock-ice mixture, hundreds of kilometers thick. Imagine diving into a sea of darkness where the cold is relentless, and the only certainty is the mystery of what could be. In these depths, untouched by light, the possibilities are as intriguing as they are daunting. Could microbial life somehow adapt to this extreme environment, finding nourishment in chemical processes that remain a mystery to us? Above this hidden ocean, Callisto's surface tells a story written over billions of years. A story of cosmic violence and resilience. Pockmarked with countless craters, the moon's surface is a testament to billions of years of meteoric impacts, each crater a scar from an ancient collision. Unlike its sister moon, Europa, Callisto bears the marks of time unabated. The lack of geological activity has preserved every impact, creating a crust that appears as a silent battlefield. Scarred but proud, an archive of the solar system's chaotic past. Each crater is like a chapter in Callisto's long history, a record of the tumultuous events that have shaped not only this moon, but also the entire Jupiter system. Yet, even in the bleakness of its cratered surface, there are whispers of possibility. Spectral analysis has revealed more than just ice. Hidden within the frozen shell are traces of water vapor, silicon rocks, ammonia, carbon dioxide, sulfur, iron, magnesium, and tholins, complex organic compounds forged under the influence of ultraviolet radiation. Tholins are particularly intriguing. Formed by the interaction of sunlight with simple organic molecules, they are the building blocks of more complex chemistry. These compounds, while fascinating, are limited in their diversity compared to the complex mix that fuels life as we know it. But they are enough to spark curiosity. They hint at chemical processes that could be happening beneath Callisto's surface, albeit in a quieter, less dramatic way than on its neighboring moons. The presence of tholins raises an exciting question. Could these organic compounds somehow contribute to the formation of primitive life forms in Callisto's hidden ocean? However, Callisto's relative calm is also its drawback. Unlike Europa, which is constantly churned by Jupiter's immense gravitational pull, creating heat through tidal forces, Callisto sits quietly, far enough from Jupiter that it avoids this gravitational dance. The absence of tidal heating means there is little internal energy to stir the waters below, reducing the likelihood of conditions favorable to life. It's a world frozen in time, a celestial body without the geologic activity that often heralds the birth of life. But who's to say that life can't thrive in the calm, in the cold, in the dark. Callisto challenges our assumptions about where life can exist, and perhaps, in its silence, it holds secrets waiting to be uncovered. In the depths of Callisto's ocean, far from any source of light or heat, life might take forms that are completely alien to us, forms that have adapted to an environment of stillness and extreme cold, existing in a delicate balance sustained by chemical interactions we have yet to understand. Callisto invites us to expand our definition of habitability, to consider that life might arise not just in dynamic, geologically active environments, but also in the quiet, the cold, and the seemingly barren. If life exists here, it is likely to be simple, resilient, and incredibly resourceful. Traits that mirror the harsh yet beautiful landscape of this distant moon. As we ponder Callisto's mysteries, we are reminded that the universe is full of surprises, and that even the most unassuming places might harbor wonders beyond our imagination. Europa, a window to a hidden ocean. If any celestial body in the solar system holds the tantalizing promise of extraterrestrial life, Europa is the brightest beacon of hope. Smaller than our own moon, Europa is a tiny world with an extraordinary secret. Beneath its smooth, ice-covered exterior lies a vast ocean, one that might be teeming with alien life. Imagine standing on Europa's frozen surface, surrounded by an endless plain of ice, with temperatures plunging to 110 Kelvin, 163 degrees Celsius, at the equator, and even lower at the poles. Despite the deadly cold, the relentless gravitational embrace of Jupiter generates tidal heating, keeping Europa's interior warm enough to sustain a liquid ocean. An ocean that might be up to 100 kilometers deep and hold twice the volume of all Earth's oceans combined. The ice shell that encases this ocean is estimated to be between 10 and 30 kilometers thick, but it is far from being an unbroken solid crust. The surface is crisscrossed with networks of cracks and crevices, places where the ice has fractured and refrozen, creating chaotic, jagged landscapes. These fissures could provide a direct link between the ocean and the surface, potential pathways for water to seep up, freeze, and then be exposed to the vacuum of space. The result is a surface that acts as a window into the ocean below, making Europa one of the most valuable targets for studying what lies beneath. Water vapor geysers have been detected erupting from the moon, reaching heights of 200 kilometers. An astonishing display of dynamic activity that hints at a restless ocean beneath the crust, constantly churning and possibly capable of sustaining life. The clues that Europa's surface holds go beyond just ice and water. Spectral analysis of the surface craters has uncovered a wealth of chemical complexity. Magnesium, sulfur, iron compounds, hydrogen peroxide, and even strong acids. These elements hint at the rich chemical diversity of the ocean beneath. The presence of hydrogen peroxide is particularly compelling, as it could serve as an energy source for simple life forms, providing the kind of chemical energy that might sustain microorganisms in an otherwise dark and hostile environment. The interaction between the ice and the ocean, facilitated by the constant fracturing and refreezing of the surface, creates a dynamic environment where chemical nutrients might be transported between the ocean and the surface, supporting a complex chemical ecosystem. Even Europa's thin atmosphere, almost imperceptible, contains a vital clue: oxygen. Though faint, this oxygen is produced by the interaction between ultraviolet radiation from the sun and water molecules in the ice, splitting them apart. This oxygen, accumulating over time, could be absorbed into the ocean, creating an environment rich enough to support aerobic organisms, life forms that rely on oxygen, much like those on Earth. Scientists hypothesize that deep below, at the bottom of this hidden ocean, underwater volcanoes or hydrothermal vents might be spewing nutrients and heat, creating a haven for life, similar to the ecosystems found in Earth's deep oceans. Here, in the warmth of underwater volcanic activity, life could not only survive but thrive, feeding on the minerals and warmth provided by the moon's internal processes. The idea of hydrothermal vents is particularly exciting because, on Earth, these environments are home to thriving communities of life, entirely independent of sunlight, sustained by the chemical energy provided by the planet's internal heat. Europa, unlike Callisto, is a moon of activity, a world of hidden oceans and icy secrets, where every crack in the ice and every plume of vapor is a clue that brings us closer to answering one of humanity's greatest questions. Are we alone? The idea that an entire ocean, hidden beneath a crust of ice, could harbor life is one that has captivated scientists and dreamers alike. It's a reminder that even in the coldest, most desolate corners of our solar system, the potential for life endures. Europa is not just a moon. It is a window into the possibilities of life beyond Earth, a glimpse into a hidden world where, beneath the ice, something extraordinary might be waiting. Imagine the ecosystems that could exist in this vast, dark ocean. Microbes clustering around hydrothermal vents, strange multicellular organisms navigating the dark waters, entire food webs existing without ever seeing the light of day. As we continue to explore, to send probes, and eventually perhaps even human missions, we are drawn by the promise that Europa might be the place where we finally discover that life is not unique to Earth. It is a place that, in its alien beauty and mystery, calls to us to dare, to dream, and to discover. What secrets lie beneath its frozen surface? Could there be simple organisms, complex ecosystems, or perhaps even something beyond our imagination? The answers may be buried beneath kilometers of ice, but the journey to uncover them is one that promises to forever change our understanding of life, the universe, and our place within it. The quest to explore Europa is not just a scientific endeavor. It is a profound journey that speaks to our deepest desires to connect, to understand, and to find our place in the cosmos. It challenges us to look beyond our world and to consider the incredible diversity of life that might exist in the most unexpected places. The story of Europa is a story of hope, of curiosity, and of the unyielding human spirit that refuses to stop searching for answers in the vastness of the universe. Saturn's rings and Enceladus's cryovolcanism. Suspended in the vast, dark expanse of space, Saturn commands attention as the crown jewel of our solar system. The planet hangs in silence, encircled by shimmering rings that seem almost too perfect, a cosmic masterpiece that defies the ordinary laws of nature. Saturn is more than a distant world. It stands as a testament to the wonder and beauty of the universe, a place where ice, dust, and rock dance in celestial harmony. It whispers stories of storms that could engulf Earth, moons that may cradle the potential for life, and mysteries still awaiting discovery. Join us as we embark on a journey to uncover Saturn's secrets, its beauty, its enigmas, and its place as a beacon of cosmic elegance in a universe full of the unknown. The magnificent rings encircle this gas giant like a celestial halo, spanning a breathtaking 280,000 kilometers in width, an expanse so vast it could almost stretch from Earth to the moon and back again. But these rings are more than just a pretty sight. They are a dynamic system of icy particles, cosmic dust, and rarefied gas, constantly interacting in an intricate ballet choreographed by Saturn's gravity. The rings hold objects ranging from boulders larger than a house to microscopic grains of ice that glimmer in the sunlight like a million scattered diamonds. Yet, despite their awe-inspiring beauty, their total mass is surprisingly modest, around 30 quintillion kilograms, making them about 2,000 times lighter than our moon. It's as if nature itself decided to craft something vast yet impossibly delicate, a testament to the wonders of cosmic balance. What if I told you that Saturn's rings might not last forever? That they are actually eroding, and we could be witnessing their final era? If true, we are seeing a spectacle that may soon vanish, leaving us with only questions and no chance for future generations to experience this wonder. Do you know anyone who would want to see Saturn's rings before they disappear? Share this video with them so they don't miss out. The rings are not just beautiful. They are alive, constantly evolving under the influence of Saturn's gravitational forces and the interactions with its numerous moons. Over time, these forces sculpt the rings, creating gaps, waves, and clumps that drift and disperse. The Cassini division, 4,800-kilometer-wide gap within the rings, is a perfect example of these dynamics. Created by the gravitational tug of Saturn's moon Mimas, which acts like a shepherd, carving out clearings and shaping the structure. These interactions reveal a finely tuned system, a dance of celestial bodies that continues to change with every passing moment, reminding us that nothing in the universe is truly static. And then there's Enceladus, a tiny moon with a huge personality. Enceladus might only be 500 kilometers across, a mere pebble compared to the giants of the solar system, but it's full of surprises. Beneath its icy crust lies an ocean, an entire world of liquid water hidden beneath a blanket of frozen stillness. Imagine the ocean's upper layers, frigid at 45 degrees C, giving way to warmer depths reaching up to 0 degrees C, kept from freezing by high concentrations of salts and ammonia. This hidden sea defies the expectations of what moons should be, a place of cold lifelessness, and instead becomes a realm of mysterious potential. But the real show happens on the surface, where cryovolcanoes, geysers of water vapor, salts, and organic molecules explode from Enceladus's southern polar region, sending icy plumes into space. These geysers replenish Saturn's E-ring, a ring that exists thanks to this tiny moon's restless energy. Beneath the crust, tidal forces exerted by Saturn's massive gravitational pull stretch and flex Enceladus, heating its interior and stirring the waters below. It's almost as if the moon itself breathes, each tidal interaction creating pressure, heat, and ultimately, those magnificent plumes. Can you picture it? A geyser, hundreds of kilometers high, ejecting particles that drift across the vastness of space, forming a faint, shimmering halo around Saturn. If that doesn't spark your imagination, think about this. Could these geysers be evidence of an alien ecosystem beneath Enceladus's icy surface? Do you think life could exist in the deep ocean of Enceladus? Imagine witnessing these cryovolcanic eruptions up close. Towering jets of water and ice spewing into the blackness of space, illuminated by the distant sunlight. These plumes are more than just spectacular sights. They are portals to the secrets hidden beneath the icy crust. The materials they expel, water, salts, and organic compounds, provide tantalizing clues about the moon's inner workings and its potential to harbor life. Scientists believe that hydrothermal vents may exist on the ocean floor of Enceladus, where heated, mineral-rich water flows out of fissures. These vents could be similar to those found deep in Earth's oceans, which teem with life despite the extreme conditions. Could there be life, microbial organisms, thriving in the darkness, sustained by the energy from these vents? This tantalizing possibility turns Enceladus from an icy moon into a beacon of hope, a place where the ingredients of life might have assembled far from the warmth of the sun. Titan, a world of methane seas. As we continue on this expedition into the unknown, we journey to Titan, Saturn's largest and most enigmatic moon, a world that challenges everything we know. Where Enceladus shines brightly with its hopeful plumes of water, Titan is an entirely different beast. Shrouded in a dense orange haze, it hides mysteries unlike any other. Here, the familiar becomes alien, and the ordinary becomes extraordinary. Picture rivers not of water, but of liquid methane and ethane, vast lakes shimmering beneath a dim, distant sun. Titan echoes Earth's landscapes, yet everything is twisted, surreal, and almost otherworldly, demanding that we rethink our understanding of planetary science and the potential for life beyond our world. Titan doesn't just invite questions, it demands them. Could its hidden subsurface ocean harbor life forms unlike anything we've ever imagined? Could its hydrocarbon lakes support bizarre organisms that thrive in conditions lethal to most known life? Titan blurs the line between skepticism and endless possibility, pushing us to expand our concept of habitability. If Enceladus whispers a promise of life as we understand it, Titan roars a challenge. That life, if it exists here, might be something wildly different, something that proves the universe is stranger than we think and stranger than we can imagine. With a diameter of 5,152 kilometers, Titan is even larger than the planet Mercury. Yet it's not its size that sets it apart, but the alien landscapes that make up its surface. Imagine a world where rivers of methane flow, carving channels across the plains, where lakes and seas, not of water, but of liquid hydrocarbons stretch across the horizon, and where mountains of ice rise against the sky. Titan's atmosphere, thick and smothering, is 1.5 times denser than Earth's and composed mainly of nitrogen, with traces of methane and ethane. These hydrocarbons, bathed in solar radiation, undergo chemical transformations, creating complex organic molecules that eventually settle on Titan's surface, a natural laboratory for prebiotic chemistry. Titan's lakes of liquid methane and ethane are like nothing we know on Earth. They sit, cold and uninviting, at a surface temperature of just 94 Kelvin, which equals to minus 180 degrees Celsius. Yet, for all its alienness, Titan's surface is striking in its own unique beauty. A world that seems eerily familiar yet wholly otherworldly. Imagine standing on Titan's surface, gazing across a lake of methane reflecting the dim orange light filtered through a dense, yellow-tinted sky. There is something hauntingly beautiful about it, like a distant echo of Earth, where similar processes of erosion and fluid dynamics sculpt a landscape so unlike anything on our home planet. Beneath Titan's icy crust lies another ocean, a body of water mixed with ammonia, which serves to prevent it from freezing solid. It's the kind of place that stretches our imaginations, that pushes us to ask what life might look like in conditions so different from our own. And then there's the weather. Titan experiences rain, but not the kind of rain we know. Instead, droplets of methane fall from the thick clouds, feeding rivers and lakes in a cycle reminiscent of Earth's water cycle. This methane-based hydrological system is a fascinating parallel to our own, suggesting that the basic principles of planetary processes can manifest in vastly different ways depending on the available materials. Titan's landscapes are shaped by these rains, with river channels, deltas, and even what appear to be shorelines marking the surface. A world sculpted by a strange, alien climate. And that's why Titan fascinates us. It's not just the lakes of hydrocarbons or the thick atmosphere. It's the potential it holds for understanding how life could arise in environments utterly alien to us. Titan is a window into what might have been, a glimpse of the processes that may have shaped early Earth before life took hold. With each passing year, we learn more, and with each discovery, Titan becomes less a frozen enigma and more a world brimming with possibilities. Its atmosphere, so similar to what Earth's might have been like in its infancy, and its lakes and seas, which mimic the water bodies that helped shape our world, make Titan an essential target for understanding not just how life could begin, but how diverse the conditions for life might be across the cosmos. The Huygens probe, which landed on Titan in 2005, gave us our first close-up look at this alien world. It showed us a rugged landscape with drainage channels, rounded pebbles of water ice, and evidence of erosion, proof that liquid in some form had shaped the surface. The mission was brief but transformative, giving us a taste of Titan's mysteries and leaving us wanting more. Future missions, like Dragonfly, a rotorcraft lander set to explore Titan's surface in the coming decade, promise to reveal even more about this strange and captivating moon. Imagine a flying robot exploring the lakes, dunes, and plains of Titan, searching for clues about the chemistry that might precede life. The beauty of these moons, Enceladus and Titan, isn't just in their dramatic landscapes or unique chemical compositions. It's in what they represent. Windows into worlds that may host life. Laboratories where the building blocks of existence might come together under conditions vastly different from those on Earth. These moons invite us to look beyond, to imagine, to question, and to explore. They are reminders that our solar system is full of wonders yet to be understood, and that each new discovery brings us closer to answering the ultimate question: are we alone in the universe? Every new piece of data from these moons adds another chapter to the story of our solar system. Enceladus and Titan are not just moons. They are living worlds, dynamic and evolving, each with a unique story to tell. They challenge our understanding of what a habitable environment might look like, and they push us to reconsider the limits of life itself. As we continue to explore, the possibilities grow ever larger, and the boundaries of our knowledge expand. These moons are our stepping stones into the vast, uncharted territories of the cosmos, and they hold the promise of discoveries that could forever change our understanding of life, the universe, and our place within it. Pluto and the mysteries of the dwarf planet. Picture this: a tiny, enigmatic world, shunned from the ranks of planets and cast to the far reaches of our solar system. The cosmic outcast, residing at the very edge, a place where the sun is no longer a mighty giver of light, but merely a bright dot in a black, frozen sky lies Pluto. An outsider, a lonely wanderer, orbiting 40 astronomical units from the sun. A realm of darkness that most of us can't even comprehend. A place where the days are frozen, the nights are eternal, and the mysteries are countless. With a radius of just 1,188 kilometers, Pluto is smaller than Earth's moon, yet it holds more secrets than one could ever imagine. Its surface temperature plummets to a frigid 60 Kelvin, or negative 213 degrees Celsius, where only the most resilient elements exist in their frozen state. Nitrogen, methane, and carbon monoxide form Pluto's icy crust, shimmering faintly in the dim sunlight, creating a world that appears as if it's locked in perpetual winter. Beneath this icy exterior, however, lies the tantalizing possibility of geological activity, a hint that this seemingly static world might be far more dynamic than it appears. But even in this frozen expanse, there is something unexpected, a sign of warmth, of life, if only in the geological sense. At the heart of Pluto lies its most distinctive feature, Tombaugh Regio, a massive heart-shaped plain that almost seems to be sending a cosmic message of affection to the universe. Within this heart lies Sputnik Planitia, a vast nitrogen ice field that has defied all expectations. Unlike the ancient, crater-scarred surfaces of other celestial bodies, Sputnik Planitia is relatively smooth, its lack of craters hinting at a geological youth and dynamism that no one anticipated in such a distant and frozen place. The smoothness suggests a constantly changing surface, renewed over time by processes that remain a mystery to scientists. Surrounding these icy plains are mountains that rise like ghostly sentinels into the darkness, Hilary Montes and Tenzing Montes, towering between 3.5 to 6 kilometers high. These are no ordinary mountains. They are formed from solid water ice, as hard as rock under Pluto's freezing conditions. They are monuments to a world that, against all odds, appears geologically alive. Some scientists believe that these towering ice formations are evidence of tectonic activity, driven by a subsurface ocean hidden beneath Pluto's frozen crust. Could there be a vast reservoir of liquid water beneath the surface of Pluto, warmed perhaps by the faint heat of radioactive decay or tidal interactions? The thought alone is enough to stir the imagination. Could life, even microbial, survive in such an alien sea? Yet there are those who argue that our obsession with Pluto is misplaced, that it's nothing more than an irrelevant ice ball, unworthy of our fascination or investment. But if we stop looking, if we dismiss worlds like Pluto, we risk missing the profound lessons they can teach us. Do you know what mysteries might be hiding beneath that frozen crust? What do you think? Should we continue exploring worlds as distant as Pluto? Or are there bigger fish to fry closer to home? And Pluto does not journey alone. It shares its path with Charon, its largest moon, locked in a celestial dance where each body forever shows the same face to the other, a phenomenon known as tidal locking. Charon is as intriguing as Pluto itself, with vast regions like Vulcan Planum, a smooth, sprawling plain that contrasts sharply with the dark, foreboding area near its pole known as Mordor Macula. These features, along with Pluto's cryovolcanic landscapes, volcanoes that spew ice instead of lava, paint a picture of a small but incredibly complex system, a dynamic world at the far reaches of the sun's influence. Charon's deep canyons and fractured surface speak of ancient upheavals, of forces that shaped this moon in ways we are only beginning to understand. The interplay between Pluto and Charon suggests that even the most remote worlds are capable of astounding complexity. Their gravitational interactions may generate enough internal heat to fuel geological activity, hinting at a level of vibrancy that challenges our perceptions of what a distant, icy world can be. The intricate patterns of fractures, plains, and mountains on both Pluto and Charon serve as reminders that the universe is full of unexpected marvels, even in the coldest and most desolate places. Pluto and Charon's story is one of resilience, of unexpected complexity in a place where simplicity seemed inevitable. They challenge our assumptions about what a distant, icy world can be. A reminder that even at the edge of our solar system, the universe is full of surprises waiting to be uncovered. As we continue to explore these outer realms, Pluto stands as a testament to the richness of the cosmos, a world that defies its small size to hold mysteries as grand as any planet in our solar system. Pluto's heart-shaped feature, its towering mountains, and its potential subsurface ocean all speak to a vibrancy that defies the cold silence of its distant location. It serves as a humbling reminder that there are countless worlds out there, each with their own stories, each waiting for us to discover them. The story of Pluto is also the story of human curiosity, the drive to understand, to explore, to find meaning in the unknown. It speaks to our determination to reach out into the farthest reaches of our solar system, to challenge our assumptions, and to accept that the universe is far more wondrous than we can ever imagine. Even a world as small and distant as Pluto can teach us profound lessons about geology, evolution, and the forces that shape the planets. If you're as fascinated by the mysteries of the cosmos as we are, make sure to like this video, subscribe for more explorations, and share it with anyone else who still believes there's wonder in the farthest corners of space. As we continue to gaze outward, we can be certain that the discoveries will only grow more astonishing, more humbling, and more beautiful. Interstellar probes and humanity's reach beyond. From the far-flung edges of our solar system to the star-studded realms of interstellar space, humanity's quest to understand the universe has reached beyond planets, beyond the sun, into the cold and infinite unknown. The pioneers of this journey are not astronauts but mechanical travelers, interstellar probes that have defied distance and time to bring us stories from the cosmic frontier. These silent messengers, Voyager 1 and 2, Pioneer 10 and 11, and New Horizons, are humanity's outstretched hands, touching the vastness beyond our familiar planetary neighborhood. Is it wise to send our messages and presence so far into the unknown? Are we prepared for who or what may be listening? Do you know what humanity might truly find in the dark reaches of space? And are we ready for the consequences? The story of New Horizons is one of audacity. Launched in 2006, it was designed with one goal: to explore Pluto, a world that for decades was shrouded in mystery. After a journey spanning nearly a decade, New Horizons arrived at Pluto in 2015, becoming the first probe to give us a close-up view of this enigmatic dwarf planet and its moon, Charon. The images and data it sent back transformed our understanding. Pluto was not a dead, frozen rock, but a complex world full of geological activity, icy plains, and towering mountains. The revelations were stunning. Vast plains of nitrogen ice, towering mountains of water ice, and potential evidence of an underground ocean. Today, New Horizons continues its journey through the Kuiper Belt, more than 50 AU from Earth, venturing deeper into the realm of distant icy objects like Arrokoth, a snowman-shaped body that offers clues about the formation of the solar system. But even beyond Pluto lies a greater frontier: interstellar space. The Voyager probes, launched in 1977, have traveled farther than any human-made object in history. Voyager 1, moving at an astonishing speed of 17 kilometers per second, has left the heliopause, the boundary where the solar wind gives way to the true vacuum of interstellar space. At over 150 AU from Earth, it is humanity's farthest ambassador, carrying with it the golden record, a time capsule of sights, sounds, and greetings from Earth, intended for any extraterrestrial intelligence that might stumble upon it. Imagine the possibilities. One day, eons from now, a distant civilization could come across Voyager, and through it, they would hear our music, our laughter, our hopes. It's a beautiful, almost poetic testament to our desire to be known, to reach out across the emptiness. The Voyager probes are more than just machines. They are symbols of humanity's unquenchable curiosity. They have not only surpassed the boundaries of the solar system, but also the boundaries of our imagination. Even now, as they drift silently through the dark, they continue to send back whispers of data, telling us about cosmic rays, the density of space, and the particles that inhabit the interstellar medium. They remind us that the cosmos is not empty, but filled with mysteries waiting to be uncovered. The data collected by Voyager has redefined our understanding of the boundaries of our solar system, revealing that the transition from solar influence to interstellar space is far more complex than previously imagined. And the future holds even more promise. Humanity's reach is extending, our ambitions growing bolder. Probes like JUICE and Europa Clipper are poised to explore Jupiter's icy moons, where vast oceans may lie beneath the frozen crusts, potentially harboring life. Missions to Saturn's Enceladus and Titan, moons with active geysers and lakes of methane, are on the horizon. Each mission a new chapter in our quest to understand the possibilities of life beyond Earth. These missions are not just about exploring distant worlds. They are about answering fundamental questions. Are we alone in the universe? What conditions are necessary for life to thrive? And how do these alien environments compare to our own? The story of interstellar exploration is the story of humanity itself. It is a story of daring, of stepping into the unknown armed with nothing but questions and the hope that answers lie out there. From the edge of the solar system to the vast stretches of interstellar space, our probes are the first scouts of an exploring species, lighting the path for future generations. One day, our descendants may follow these paths, traveling to distant stars, setting foot on alien worlds, and expanding the boundaries of human knowledge and experience. The dream of interstellar travel, once confined to the realm of science fiction, now seems just beyond our reach. A tantalizing possibility that drives us forward. As we stand today, at the dawn of this new era, we can only wonder what secrets await us, hidden in the darkness, waiting for us to find them. The universe is vast, mysterious, and full of potential, and our journey has only just begun. We are explorers at heart, and as long as there are questions to be answered and horizons to be reached, humanity will continue to reach for the stars, propelled by curiosity and the unshakable belief that there is always more to discover. The future of interstellar exploration lies not just in technology, but in our unwavering commitment to understanding our place in the cosmos, to seeking out the unknown, and to embracing the challenges that lie ahead. Each new discovery, each new horizon reached, will bring us closer to understanding the profound mysteries of the universe and our role within it.